Okay, we are taking a quick little review, and I'm going to talk about Chapter 13.1 and 13.2 because they're really sections that we've done. Aside from some of the word problems in those sections, we have gone through. So I want to talk about our different ways to solve quadratics. When we have a linear equation, we solve for x. We get x alone. That's when x is to the first power. And there's one solution. When we have a quadratic equation, that means there's a squared term, and generally there's going to be two solutions. The first method we learned was how to solve it by factoring. We factored it, we set it equal to 0, and then we found the factors that multiply. All right. We talked about putting the equation in standard form, right? In ax squared plus bx plus c. So if I'm using this, I would put it still to standard form, and I would subtract 36 so that I'm in the same form as standard form. Now, what am I missing here? What am I missing in 4x squared minus 36? Yeah, we're missing the b term. So we're still in standard form. We're just missing that b term. And then we factored that. We said 4 times x squared minus 9 times the quantity of x squared minus 9. And then we broke that down into x plus 3, x minus 3. And we set them equal to 0. And we found out that our two solutions were 3 and negative 3. Thumbs up if you're remembering this. Thumbs down if you don't. Okay. I'm going to skip through all this. And then we went through. So giving something like this, we'd factor. Set them both equal to 0. In this case, it was x cubed, so we likely have 3 solutions. This is an exception because it's a perfect square trinomial, so the factors are exactly the same. So there's only 1 5 on the number line, okay? And then what if it's not all equal to 0? What do we need to do?
Make it equal to 0?
Yeah, we set it equal to 0. We add 45n to both sides, put it in standard form. We GCF. We factor what we can. This becomes an x plus 3. N plus 3 times n plus 3 times 5n. And my solutions, 5n equals 0 and n plus 3 equals 0. So my solutions are 0 and negative 3. Okay? Any questions there? Same thing here. I'm setting it equal to 0. I factor my GCF, and then I factor. Everybody remembering this?
Yeah.
Okay, so we're going to go over to the next section. Going to the second method. The second method we learned was how to solve quadratic equations using the square root method. In this case, we wouldn't set it equal to 0. We would get the quadratic alone. Okay, we get the quadratic alone. And the quadratic alone ends up, we take the root of both sides, and once the quadratic's alone, then we can root both sides, and then we get the absolute value of a number equals 3. Well, to lose the absolute value, we set it equal to plus or minus. Is everybody remembering that, especially the absolute value work? Okay, as they get more complicated, we're still doing the same thing. These aren't more complicated. In this case, if they're not a perfect square, we keep it under the radical. Okay? If they're not set equal to the quadratic, then we get everything, we move everything away from the quadratic to the other side. So I would do this. I get m squared equals 13, root both sides. Absolute value of m equals rad 13, and we're left with plus or minus 13, rad 13. Okay, questions? Are we remembering this? They're going to get more complicated. Again, if we're using the square root method, I get y squared alone. So I would add 20, then divide by 3. Then I root both sides, if I'm using the square root method. Again, just a separate method than our factoring method. Absolute value, y equals plus or minus. Remembering this? Okay. In this case, notice when I get here, and then I go to root, what's going to happen? I get here, I root both sides.
A negative under the radical.
We get a negative under the radical, so what do we say? No solution. Okay? You actually probably could have seen it right here.
Yeah.
Right? All right, so having no solution. So now we are ready really to move on to, oh no, one more. What do I do? Is the quadratic alone?
Yes.
Yes, it is. The quadratic happens to be a binomial this time. So what do I have to do, Gracie?
Still, you root both.
We root both sides, and then we get the absolute value of y plus 1 equals 4. To lose the absolute value, I'm doing y plus 1 equals plus or minus 4. Okay? Then subtract the 1, and we're left with y equals negative 1 plus or minus 4. So negative 1 plus 4 and negative 1 minus 4 is,
3 and negative 5.
yep. Okay. Pause the recording if you want to take notes on that. Now try number 10. Let's check our work. Forgot that doesn't work. Okay, and you should have gotten 8 and negative 2. Is everybody remembering this?
Yep.
Okay, is there a question, Grant?
No, I'm fine. I must.
All right, so we are going to go on to actually, now is our section called completing the square. Very important method. Very important method. So, if you're going to write this, write fast, because we don't have 10 minutes for you to write. Write this page, okay? You can always go home and finish it. So there are a number of different ways to solve a quadratic. The first was the square root method. It wouldn't work with a linear term, okay? Graphing method, it sometimes works, but sometimes it's hard to tell when you're in between the boxes. Our quadratic formula always works. Easiest method. Figure out your A, B, and C and plug it into a formula. Always works. Factoring method. Works a lot of time, but not every time. Everything's not factorable. Okay? And then the last method is that we're going to talk about is completing the square, and that's what we're doing today, completing the square. Okay? This is by far the most tested method you will be tested on. Quadratic formula, probably, like I remember my son's old teacher never used quadratic formula when they were solving. So you will always, and you will also have to derive the quadratic formula. Oh, well, by completing the square. So we'll get to that one on quadratic formula day. All right, questions? Can I move on? Okay. So completing the square. The first thing we're going to do is we're going to turn this into a perfect square trinomial. Okay? So to do that, remember there's A is what in this equation? What is the value of A? No. 1. What is the value of B?
6.
And the value of C? Okay, we're going to move our C. So we can turn this into, so I'm going to move C. I'm going to add 7 to both sides. And then we're going to move 7 to both sides. And then what do I need to do to make this? What number would go in here to make it a perfect square trinomial? Right? What'd you say? Yeah, 9 goes in there. So if I add 9 to this side, I have to add it to this side. We're using our properties of equality, keeping everything in balance in the equation. Okay. Now, that's something we can factor. How do I factor that? How do we factor that?
Quantity of x plus 3.
The quantity of x plus 3, right? When I add that 9, that is completing the square. When I add the 9, it is completing the square. So I can factor that left side to x plus 3. The quantity of x plus 3 squared equals 16. Okay? What do I do now? Same thing we did on the last section. We root both sides, not square, the opposite. We're going to root both sides. And what is the square root of the quantity of x plus 3 squared? The absolute value of x plus 3 equals 4. Okay? So then I've got x plus 3 equals plus or minus 4. What am I doing now? Subtracting 3. X equals negative 3 plus or minus 4. Negative 3 plus 4 and negative 3 minus 4. Negative 3 plus 4, negative 3 minus 4. So that would be 1 or negative 7. 2 solutions. Now, how did you know to put the 9 in there?
Because the 9 going there would make it a perfect square triangle.
But how did you know that that would be the number?
Well, I did what plus itself equals 3, and I got.
How did you know to do what plus itself equals 3?
Because of the x marks the spot method.
Oh, so he did x marks the spot and said what adds to 6, and we need 2 of the exact same things.
And I got 3 and 3. And then
3 and 3, and then he multiplied them and got 9. Okay? Now, all right, so again, if I were doing the binomial method, what plus itself equals 6?
3 and 3.
3 and 3. So this would be x plus 3 squared, and what goes in here now? 9, okay. What's the binomial that goes in here? M? No, M plus 6, and what goes in here? Good. Okay, what's this going to be, Nicole?
It's going to be y minus 9
Squared.
squared.
And then what goes in here?
It's going to be 81.
Yep. Okay, and the next one, let's go, Julia.
K minus 7,
Good. And then what goes in here?
41.
41?
I'm so confused. I'm really lost.
Where'd you get 41?
I was just kind of following.
Yeah, what's the pattern? You're right, you should be following a pattern. You should be following a pattern. You should be following a pattern. Huh?
39.
Thank you. Okay, now the only one that's kind of tricky is we know that the root of this is this. 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 So what's the root of this?
2t.
2t. Now it has to multiply by something. What sign is it going to be?
Minus.
A minus sign because we've got that minus here. Now what number must go in there? Notice every time when I multiply these together, I get negative 7k. What relation does it have to this? So then I would multiply by 2, right? So 2 times what goes in there?
Negative 5.
Negative.
No, wait, negative 10. Negative 10.
Notice here, when I multiply it, it's negative 9y. Here it's 6m. And when I double it, I get the middle term. When I double it, so what goes inside this parenthesis? Negative 10t, and so what would have to go here? Yep. I didn't know if it was going in the right place. Okay, so when I square that, right, 2t times negative 5 is negative 10t, double it, and I get the middle term. So what goes in this box now?
25.
Yep, 25. You get the idea? All right, yeah.
Couldn't you also divide both sides by 4 and get t squared minus 5t? And then you just...
So you get t squared minus 5t, t squared, so you're going... You're dividing both sides by 4. Okay, how are you getting this in here?
The 25. You would do 5 times 5 since it's squared.
Not one time are we multiplying that and squaring it. So I don't know, that logic's not. All right, so let's go on and continue completing the squares. So what would I do first, Aitan? Aitan.
You would subtract 5.
Yeah, clear out the space. Subtract 5. You should be writing as we're going. Creates muscle memory. Now what? What's next?
16.
Adding 16. How are we getting that 16? Instead of just remembering what that trinomial is, what's the pattern to getting it? Yeah.
What plus what, or what plus itself equals 8, and you get 4, then 4 squared equals 16.
Okay. Anybody else? Can anybody else come up with a formula that might? We know that this is ax plus bx plus c, right? I mean, ax squared plus bx plus c, right? So equals 0. So what's the formula to figuring out what that c is?
C equals 2b. No, wait, that doesn't work.
What do I do to b every time? Okay, so I'm taking the b, not x, negative 8. We're dividing it by 2. So b divided by 2, and then what do we do with it?
Square.
And then we square it. There we go. So you've created that formula. So in this case, we're doing negative 8 divided by 2 is negative 4 squared is
16.
So I'm adding 16 and I'm adding 16. Okay? Okay? What do I get? What am I doing? Next. X minus 4 squared equals 11. Now what? We're going to root both sides, and I get the absolute value of x minus 4 equals rad 11. It's not a perfect square, so we're not going to estimate it. Unless it's a story problem, I likely will leave it under the radical because it's far more accurate. So now I have x minus 4 equals, to lose the absolute value, we have to set it equal to plus or minus. And then I'm saying add 4. Do not leave it like this. You got to get x alone. Add 4, and so x is equal to 4 plus or minus the square root of 11. Another thing that this would be, if I were, this is a perfectly good answer if it's not a word problem. If it's a word problem, you're likely to have to estimate that. So square root of 11 falls between what? So this is 3, this is 4, about 3 point what? 3.3? What did we say about 3.3? So this would be 4 plus 3.3 and 4 minus 3.3. And so that is 7.3. Okay? Questions? See what my PowerPoint looks like. It's probably much cleaner. Okay. So do you see how they just leave it under the radical? Unless it's a word problem, we don't want you estimating because it's more accurate under the radical. When we estimate, we're cutting off decimals. All right. So here's where we really need that formula that you guys just derived. So what's the first step? Writing this down. Writing this down because the next one you're doing on your own. Okay, what's the first step? Good. Now what do I have to do to complete the square?
Put the negative 5 into the formula and plug it in.
Negative 5
Divided by 2 squared.
Divided by 2 and then square the whole thing. So negative 5 divided by 2. Don't worry about that it's a fraction. Square it. What happens when I square it? It becomes positive or negative? Positive. What in the numerator? 25. What in the denominator? 4. Okay? If I add it to one side, I have to add it to the other. Now, it's really pretty easy from here, this fraction work. Do not convert this to a decimal. It will be much more difficult. Now, this side is pretty easy because when I have like x squared minus 18x plus 81, okay, how do I factor that? What's the root of that? What's the root of that?
9.
We know it's there. Isn't that easy? We know that we just check our middle term. That times 2 equals that. But it's pretty easy. So how do I factor this now? What's the root of this, Nicole?
X.
What's the root of this?
5.
Over?
Over 2.
Good. And what sign must it have to have this negative here?
Minus 7.
There you go. You just factored it. And this, I have to have it have a common denominator. So I got to multiply by 4 over 4. And we end up with negative 24 over 4 plus 25 over 4. So now I'm doing x minus 5 over 2 equals what is it? 1 over 4. Now what do we have to do? We root both sides using our square root method. I get x minus 5 over 2, absolute value, equals 1 over 2. It's getting easier by the second, right? I'm going to add 5 over 2 to 1/2, plus or minus 1/2. And I get 6 over 2, which is 3. And 4 over 2, which is 2. Questions? Okay, this time it's your turn. Pause the recording as soon as I get to the next question. And I want you to try the next one. Now, the only difference is there's no C here. But you can add something to both sides. So pause the recording and go. All right. Oh, gosh, this is rough, huh? Okay, here we go. All right, so what do we do to both sides?
I divided by 2.
Uh-huh.
And I got negative.
You divided what by 2?
The b.
Okay.
I got negative 7 over 2, and then I squared it, so I got x squared minus 7x plus 49 over 4.
You added 49. So tell me what you're doing here in this next step.
So I add 49 over 4 to both sides.
Both sides of the equation. Positive or negative?
Positive.
Good. Okay. And then?
And then I square them.
Not yet. Before you square. If I square 49, that's going to be an awfully big number. What do I do next?
I got x minus 7 over 2.
Okay, that's not, what's that called? Tell me the correct name of the procedure. What?
Factoring.
You factored it. So you factored the left side. Okay, you factored and you got x.
The quantity of x minus 7 over 2 times 2 squared 2. And then I got plus 49 over 2 on the other side. And then I
49 over 2.
40. No, over 4.
Good. Okay, and then what do?
And then I squared both sides.
You're not squaring, you're rooting. You need to figure out how to say it properly. To root is different than to square. They're opposites. Okay, so what are you doing now?
So I rooted both sides.
Okay, and you get?
I got the absolute value of x minus 7 over 2 equals plus or minus 7 over 2.
Equals 7 over 2, and drop the absolute value. Okay, and then?
And then I got confused here.
Well, you then...
X equals negative 7 over 2 plus or minus.
No. From here, to get rid of the 7 over 2, you have to add 7 over 2 to both sides, right? So now what this becomes is this. X equals 7 over 2 plus or minus 7 over 2. Now that is two different problems. 7 over 2 plus 7 over 2 and 7 over 2 minus 7 over 2. It's 49 over 4. No, 14 over 2, sorry. What was I doing there? 14 over 2, which is 7. And this would be 0. So my solutions are 7 and 0. Got it? Okay. Let's keep going. Okay. When we have a lead coefficient, we're doing the same thing. Clear it out. Clear out the space. What do I do first? Add 4 to both sides. Now, I've got that empty space there for C. But before we do that, I want to get rid of the lead coefficient. So I'm going to divide both sides by the lead coefficient. That means all terms. Okay? So that means this is over 2. Everything's divided by 2. Here, the 2's are going to cancel. So I kind of like to do it this way. Because I want you to know really quick. If the lead coefficient is 2, you're dividing both sides by 2. This is divided by 2, this is divided by 2, this is all terms by 2. Is that clear? Yes. Now here you can see they cross cancel and we're left with x squared plus 7x over 2 x equals 2. And I'm going to leave a little space there for me to complete the square. Oops. Is that making sense? Okay. Now, how do I get that? How do I complete the square? What do I have to do to that middle term, that b term?
Divided by 2.
So 7 over 2 divided by 2, and then we square it, right? But what does that really mean? That means 7 over 2 divided by 2. Isn't that the same thing as 2 over 1? But we don't divide fractions. Instead, we really... Okay? And so it becomes 7 over 4. So my new is 7 over 4 plus 7 over 4. Now over here, I'm going to have to multiply by 2 over 2, right? Did I square it yet? No. I'm not doing that yet. I made a mistake. So it's 7 over 4, but then remember we had to square it. So I got 7 over 4 squared is what? 49 over 16. Okay, sorry about that. So I'm adding 49 over 16. I'm adding 49 over 16. Now, what's the common denominator on the left side? 16. So I'm going to have to multiply by
8
over
8.
Good. And over here, we get to factor. What does this side factor to? How about Nicole? What does the left side factor to?
You get x squared plus 7 over 4.
What does this factor to? It's not x squared.
Oh, x. plus 7 over 4.
Good. Squared.
Squared.
Equals, that becomes 6. No, that's not going to work. I multiplied by the wrong thing. I have to multiply by 16 over 16. So that's 32 over 16 plus 49 over 16. And I think this is going to be really pretty. I'm going to erase this. Can I erase it all? Mm-hmm. Put it in PowerPoint form. It's going to be very pretty. So 32 over 4 plus 49 equals 81. These numbers are looking prettier and prettier every minute. So Julia, what am I doing next? Okay, so I'm rooting both sides. And on this side, what are we going to get? On the left side?
X plus 7 over 4.
Equals?
9 over 4.
Perfect. And then to lose the absolute value, right, we set this to the positive or negative. What would I do next, Julia?
You subtract 7 over 4 from both sides.
Okay. And we end up with x equals 7/4 plus 9/4 makes what? Negative 7/4 plus 9/4, negative 2/4, right? No, it'd be positive 2/4. And negative 7/4 minus 9/4 makes negative 16/4, which is 1/2 and negative 4. Okay, questions? So do you understand what to do with the lead coefficient? Julia, what point did you get confused? Did you just get confused because of the lead coefficient, or are you confused on the whole process?
I get confused on how you figure out what you're adding, like the add plus.
Okay, so every time you take what's here, you have to divide it by 2 and then square it. We take the middle term coefficient, 7 over 2. We have to divide it by 2 since that's the middle term. It's kind of hard here. So 7 over 2, we have to divide it by 2 and then square it. Doesn't this equal 7 over 2 times divided by 2 over 1, right? Isn't that the same thing?
Yeah.
And we don't divide fractions, so instead we multiply by the reciprocal.
Okay.
And then we still have to 7 over 4. So do you understand? This one happened to be a little bit more complex than normal. Were you able to do it when you didn't have the lead coefficient? Or were you confused every time?
No, I did it for the other ones, just the lead coefficient.
Okay, questions? Okay, here's one more problem. If you want to practice it at home, try it. Pause the recording. Okay, now check your work. And remember, it's okay in an answer to be, look at guys, look at, Nicole, I'm waiting on you. It's okay. Notice what I do here. I put it all over 6. Leave it under the radical. If it's not a word problem, don't estimate it. If they're not asking you how long it takes for the penny to drop, in that case, you're never going to use the square root of, it takes me the square root of 13. We need you to estimate your seconds. Okay? Questions? All right. We completed the square. We're out.